Hello everyone, my name is Kusal Bandari and today I'll be presenting my final project for Automata theory titled Sequoia Parsing Project in the domain of computing related questions. So let's begin with the project purpose and domain. This project demonstrates syntactic parsing of computing related natural languages questions using the CK algorithm. The main goal is to simulate how grammar-based systems like virtual assistants or compilers can verify whether a given computing-related query is grammatically correct or not. The domain includes questions related to programming, AI, system tools, and concepts like what is machine learning or can you suggest tutorials for SQL. So let's go to the some valid sentences. Here are three valid sentences I have explained from altogether 15 sentences. So let's take can you recommend me a book on Python? Here I have mentioned with the CKI parsing table as well, and likewise what is machine learning, and also for this I have attached the CKI parsing table for this sentence too. I'll explain about this a little bit later. And another sentence is what is object oriented programming, and the CQI parsing table is shown in the diagram. And some of the invalid sentences I have mentioned is what can do software engineering you, and the CQI failure table for these sentences I have also attached for here. And can you recommend Python book me? This is another invalid sentences. And what algorithm reinforcement is learning is the final invalid sentences I have explained with the CK failure table too. Let's get to the CFC structure. To process these queries, I first constructed a context-free grammar that reflects real English syntax in computing questions. The start symbol S can expand into common forms like S tends to W, as AUX, NP, BP, and yes tends to pronoun VP, and yes tends to BP and NP. I defined noun phrases, verb phrases, prepositional phrases, and handled auxiliary verbs like is, does, and can. And for the CNF conversion, what I have done is I converted the CFG into CNF, which is required by the CQI algorithm. This involved four main steps. So removing productions and unit productions, and also eliminating the unit productions, also replacing terminals in mixed rules with new variables, and then breaking long productions into binary ones, and used intermediate non-terminals like x1 tends to did noun. For example, NP did noun and VP verb NP are now in CNF. CKY parsing strategy. The CKY algorithm works bottom up. Each word is triggered, tagged with its grammar category. Then using CNF rules, we combine words and phrases level by level. If we can build the start symbol S in the top right cell, then the sentence is accepted. This approach is systematic, rule-based, and deterministic too. Okay, so let's take an examples. Like I have shown earlier the CQI parsing tables for 3 valid sentences, and for CQI failure tables for 3 invalid sentences. Let's talk about them for a little while. Like in this example, like can you recommend me a book on Python? The parser correctly builds a path through the table and places S at the top right corner, proving they are syntactically correct. Each cell in the triangle shows how two smaller constituents combine. For example, did plus noun equals to NP, or verb plus NP tends to VP. So their verb pronoun. So it was the example for the correct sentence, like valid sentence, and for the invalid sentence, like for example, like what can do software engineering you. So you'll notice that while the bottom row correctly tags each word, the combination in higher cells failed to produce a valid path to yes. So these structural issues block the derivation of an yes symbol, and the parser rightly rejects the sentences. So talking about the summary, I created a completed CFG and converted it into CNF for computing related queries, and all the 15 valid sentences successfully parsed to the point yes, so that's they were valid, and then 3 invalid sentences failed to derive to yes, so they're invalid. And CQ algorithm confirms grammatical validity and recognized all valid inputs and rejected incorrect ones. So and then CFG and CNF worked for realistic computing queries. This shows how formal grammar and parsing algorithms can be applied to real-world natural languages tasks, especially in specialized domains like computing. Thank you for your attention. If you have any questions, I'll be happy to answer them. Thank you.